users now have the option to set solid models as turning tool holder geometry. This gives much more accurate simulation of turning feature operations and provides a lot more confidence when checking for collisions. In this example, you'll notice that we have this ring sleeve part that we're going to actually create some geometry holders for. But we're going to utilize solids to allow us to do this. You'll notice in the rolling demo window we have a folder icon. If we open that folder icon, you'll see that we have a Parasolid file for the holder. We also have the pre-saved tool crib, which has the tools currently saved in the part, and we also have the Akuma Multus CNC file and a special MD file that is set up in this case for our Sandvik Capto tooling. What I'm going to do for the time being is I'm just going to turn off the groove and cut-off operations. We're going to create the tool for the facing, turning and boring operations. Running a 3D simulation, you'll notice that's the turning shape so far. So what I'm going to do is I'm going to go up to my options, into the simulation, I'm going to turn on show holder. What you'll now see is the variation of different holders and different inserts that are being used for the various operations. So now we can see we have the boring bar. So this could all be done with one particular holder. So we're going to change the holder that we're using. So the first thing I want to do is I'm going to go into my facing operation, into the properties. Under the Finish tab, you'll notice that we're using a southwest turn 80-degree insert tool. What I'm going to do is I'm going to create a copy of this tool, and we're going to call this TNGA, and then we're going to signify a tip radius of 0.8 of a millimeter and 16 millimeter for an inscribed circle diameter. I'm going to change this to be a millimeters tool. I'm going to change the insert type to be a triangle insert and fill in the values. A preview will update the view, and you'll notice that we also need to change the holder geometry. So I'm going to go into the holder geometry and set the values 3 degrees for our side angle. We're going to set a shaft width of 32. We're going to set a length of 130 millimeters, an exposed length of 110 millimeters, and a distance from the tip to back of 22 millimeters. So at the moment we have our holder geometry, and we're also going to change just the direction of cut. In this case, this is an end cutting tool, not a side cut. So this is our tool saved so far. So we can say OK, allow the programming point to reset, and set the tool as override. This is the tool we're going to work with, so let's apply. So now I need to bring in my holder geometry. In this case I'm going to import the solid from that folder location. So going back to the browser, clicking on the folder icon, you'll notice I have a Parasolid file for a C6 PTFNR. I'm going to drag and drop straight into the FeatureCAM window. I'm going to import, but I'm not going to go through the wizard. I'm just going to simply cancel. You'll now notice that I have my new solid here in the window. I can rename this if I wish to do so, again calling this C6-PTFNR. So that's my solid holder. I'm going to hide everything except that solid holder, and viewing from the top you'll notice that we have the insert position located around here. So what we need to do is we need to take a sketch and find the mounting point or the 0 point of this holder. So again I'm going to hide everything except these two faces. I'm going to create some sketch lines simply between the key points. So I now have my line geometry. I can hide those faces, and then I can use the trim extend just to pull my lines so that they cross each other, and then I can clip. So that gives me my point to move the holder geometry. So let's say show selected, bring that tool back. So now I need a reference point to move this to. In this case, I'm going to go back into the facing operation, into the properties, into the finishing tab, and under the tool I'm going to go to the holder drawing area. So you'll notice that we have a new option for curve or solid. So to give me my reference point, I'm going to use the curve and simply paste an example of the curve into my FeatureCAM window and cancel. You'll now notice, if I turn the shading off, you'll see my insert position and my holder geometry. So all I'm going to do is select my holder. I'm going to provide a transform, just simply going from my corner point position there, and simply going to, in this case, the location of a holder position. So I can snap to that key location. Preview the holder position. Everything looks okay, so I can accept. Turn the shading back on. You'll now see the position of the insert relative to our holder geometry. These curves can now be deleted. So looking from the side here, you'll also notice that we have a step distance where the recess of the insert will sit. So I'm going to take a measurement of this, just simply taking a linear distance between two key points, and you can see we've got approximately 2 millimeters. So for the sake of simulation, we're going to simply move the holder down the y-axis in 2 millimeters. So again, another transform, this time selecting the solid again, into the transform. I'm going to simply set 0, moving down the y-axis, -2, 0. So okay. The wireframe geometry that I used before can now be deleted, and I now have my holder position correctly orientated, ready to combine in the tool. So let's go back to that facing operation, into the finishing tab. I'm going to select my insert. Under holder drawing, I'm going to select solid this time, and you'll notice that this becomes populated, and I can choose my solid. In this case, I'm going to select that C6 and choose set selected. You'll notice that the preview window shows the insert position and the holder geometry. I can now accept that, and this tool is now updated and used for my facing operation. So I can now choose to hide this. I'm going to show the ring sleeve. Running a centerline simulation, you'll notice that I now have my tool holder geometry. Because of the orientation of this tool, or the type of tool, this Capto type tooling, I can also use it for some of the other operations that I have in the tree. So I'm simply going to select all these operations and override with that tool. I now need to orientate the B-axis for this Maltus machine to position the tool correctly. So in the turn operation, I'm going to select the roughing tab. Notice the direction of the tool at the moment. I want to be cutting with this end here. So I'm going to set the B-axis orientation, orientate it as if it was a boring bar, but facing west-south. Apply, and again you'll see the update. Repeat this process for the finishing. And we also need to do a similar operation for the boring. So into the roughing tab, into the B-axis options, ID boring bar, but this time west-north. And again repeating for the finish. Our tool is now orientated correctly. We can also turn on the grooving operations, which in this case are using a C3 type holder. So those have already been done for you. We can now run through our simulation, initially as a 3D operation. So there is my facing. Tool then indexes round. And we can start cutting the outside turn. And again index round and cut the bore operation. There is also the grooving tool, which allows us to groove the two groove areas, and this tool can also be used for the cutoff. So final thing to show is the machine simulation. In this case we have this Akuma Multus, and it's been specifically designed for the Capto type tooling. Let's run that a bit slower, just to verify. The part's complete.